So I just finished watching Three-Body Problem on Netflix, and I had to know, is this actually real physics or just sci-fi nonsense? I started with what seemed like a simple question about three objects in space, but what I discovered sent me down a rabbit hole involving Isaac Newton's crisis of faith, Napoleon reading physics textbooks, and why our solar system shouldn't exist but somehow does. Let me show you what I found. Picture this. You're standing on a beach at night, watching the moon rise over the ocean. That moon isn't actually orbiting Earth, not the way you think. Both Earth and moon are locked in an eternal waltz, spinning around an invisible point between them. This point, their mutual center of gravity, sits 1,700 kilometers beneath your feet, buried deep inside Earth's mantle. Every 27 days, our entire planet performs a subtle wobble around this hidden pivot, like a hammer thrower spinning before release. When Isaac Newton published his Principia Mathematica in 1687, he gifted humanity something extraordinary: perfect predictability. With just pencil and paper, he could tell you exactly where the moon would be on any date, past, present, or future. Two objects, one equation, infinite precision. The mathematics sang in perfect harmony. Binary stars dancing for billions of years, the Earth-Moon system keeping time like a cosmic clock, all of it reducible to elegant equations that would fit on a napkin. For 2 centuries, this was enough. Astronomers could predict eclipses down to the second. Sailors navigated oceans using Newton's clockwork universe. The two-body problem wasn't just solved, it was conquered. Here was proof that the universe operated on knowable laws, that chaos could be tamed by human intellect. But then Newton made a fateful decision. He added Jupiter to his calculations, just one more sphere of gas and gravity, and the elegant mathematics shattered like crystal hitting stone. Newton's pen trembled as he calculated Jupiter's influence on Earth. Every 12 years, the gas giant swings past, its gravity reaching across 600 million kilometers of void to tug at our home. Not much, just a whisper of force. But whispers, Newton realized with growing dread, could accumulate into screams. The mathematics that had been his triumph now became his torment. Where two bodies produced clean ellipses, three bodies spawned equations that writhed and twisted, refusing to resolve. Newton spent months at his desk, candles burning to stubs, trying to prove Earth's orbit was stable. He couldn't. The greatest mathematical mind of his age had met his match in 3 simple spheres. His solution reveals the human behind the genius. In the 1713 edition of his Principia, Newton wrote something remarkable. This most beautiful system of the sun, planets, and comets could only proceed from the counsel and dominion of an intelligent and powerful being. Translation: God must periodically reach down and nudge the planets back into place, like a celestial clockmaker adjusting the gears. Think about that. The man who decoded gravity itself, who reduced the heavens to mathematics, ultimately threw up his hands and said, "God fixes it." This wasn't just scientific frustration. It was existential terror. If 3 bodies could defeat Newton's laws, what did that mean for a solar system with 8 planets, dozens of moons, and millions of asteroids? Were we living in cosmic chaos, held together only by divine intervention? For 113 years after Newton's death, this question haunted astronomy. The solar system shouldn't work, yet here we were, still orbiting. Enter Pierre-Simon Laplace, born to a Normandy farmer in 1749, who would become Napoleon's favorite scientist. Where Newton saw divine intervention, Laplace saw a mathematical challenge. Armed with new mathematical tools, calculus techniques that Newton himself had invented but never fully exploited, Laplace attacked the problem with French revolutionary fervor. Picture the scene. 1802. a glittering scientific salon in Paris. Napoleon Bonaparte, fresh from conquering half of Europe, fancied himself an intellectual. He had actually read Laplace's 5-volume Celestial Mechanics, all 2,500 pages of it. The emperor, perhaps hoping to catch the great mathematician off guard, posed a loaded question. "Monsieur Laplace, Newton found it necessary to invoke God to keep the planets in their orbits. I notice you have not mentioned the Creator even once in your lengthy work. Why?" The room held its breath. To contradict Newton was bold. To dismiss God before Napoleon was borderline suicidal. Laplace adjusted his cravat, looked the emperor directly in the eye, and delivered one of science's greatest mic drops. "Sire, I had no need of that hypothesis." What Laplace had discovered was perturbation theory, a way to calculate how multiple gravitational tugs accumulated over millennia. Think of it like predicting ocean waves. You can't track every water molecule, but you can predict the tide. Laplace proved that Jupiter's pulls on Earth weren't random. They followed patterns that canceled out over centuries. The solar system didn't need divine maintenance. It was self-correcting, like a tightrope walker who sways but never falls. Yet even Laplace's triumph had limits. His mathematics worked when one massive object dominated, like our Sun, which contains 99.86% of the solar system's mass. But what happens in a system with 3 stars of equal size, where no single gravity source rules? This is where our journey reaches its destination, and where Netflix's 3-body problem begins. 3 stars of equal mass, locked in mutual orbit. No dominant partner, no stable center. Just 3 titans wrestling for gravitational supremacy, and the mathematics descends into pure chaos. In 1887, Henri Poincaré proved something that shook physics to its core. The 3-body problem isn't just hard, it's fundamentally unsolvable. Not unsolvable with current math, but unsolvable period, like asking for the last digit of pi. Change the starting positions by the width of an atom, and after a few thousand years, your 3 stars could be light years apart or colliding in stellar catastrophe. Modern supercomputers at NASA's Jet Propulsion Laboratory can simulate these systems. Watch their visualizations, and you'll see something hypnotic and terrifying. 3 points of light tracing paths that never repeat, never stabilize. Sometimes they dance in elegant figure 8s for centuries, then suddenly one star gets ejected into interstellar darkness, while the other 2 form a tight binary. Run the exact same simulation with positions changed by 0.000001%, less than the gravitational effect of a butterfly landing on Earth, and you'll get completely different outcomes. Dr. Lisa Kaltenegger at Cornell puts it perfectly. Each 3-body system is a unique puzzle, with orbits that can resemble anything from tightly choreographed dances to erratic, unpredictable movements. No 2 systems are the same, and that's what makes predicting their behavior so complicated. She pauses, then adds with a slight smile, "If you lived on a planet in a 3-body system, you wouldn't have seasons or regular days. You'd have chaos. Some years might last decades, some just weeks. Your civilization would never develop astronomy because the sky would never repeat its patterns." This isn't science fiction. We've found real 3-star systems. Alpha Centauri, our nearest stellar neighbor, is actually 3 stars locked in a complex gravitational embrace. HD 188753, 149 light-years away, has a planet orbiting in a 3-star system where the sky hosts 3 suns of different colors, white, orange, and red, rising and setting in patterns that would drive any calendar maker insane. So when Netflix shows a planet with 3 suns creating unpredictable, chaotic eras and brief, stable eras, that's not Hollywood exaggeration. That's genuine astrophysics. The show's title isn't just a name, it's a declaration of mathematical impossibility made real. The three-body problem taught me something profound about our place in the universe. Here we sit, having built machines that can predict eclipses in the year 3000 and land robots on Mars with pinpoint accuracy. We've decoded DNA and split the atom, yet add just one extra sun to our solar system, one more gravity source to the cosmic dance, and all our mathematics, all our supercomputers, all our genius becomes worthless. The universe transforms from clockwork to chaos with the addition of a single sphere. Sometimes the simplest questions have the most mind-bending answers. Three objects in space. That's all it takes to humble humanity. If you enjoyed this story, hit the subscribe button for more fascinating historical deep dives every week. Thanks for watching.